All right, so looking at logs, derivatives of logs. Natural log is a log of base, you know what goes in that blank?
1.
Oh, not 1, not 10. E. Right? If we wrote log base E, that's the same thing as natural log. Log base E of x would be the same thing as natural log of x. And because base E, it actually occurs in nature quite a bit, so it happens a lot. It's also a very calculus-y thing. They decided, well, you know what? Let's make that its own special thing. Let's call that natural log.
When does it happen in nature?
That's a good question. I don't know the answer, but the log natural, like it's a French thing. That's why it's abbreviated that way. Like the N of ln is natural, and so it did come from nature. And I don't remember what about nature has E in it, but it does. I know. Like, oh, don't you see the E's growing on the tree out there? Like, and then not quite.
Natural log is the first.
Natural log of E. So that means
What is going on?
log base E of E is 1. But I hope you don't have to think through it every time. I hope you just remember the natural log of E is 1. Or if you do have to think through it, at least you don't have to write it out. You just think E raised to what would give me E. Same thing with natural log. E raised to what would give me 1?
0.
E to the 0 would be 1. And then I cannot star these properties enough in terms of their usefulness. Let's see, do you remember what happens? I don't want to use the word distribute. Natural log of xy, do you remember how we could split that up?
No.
Natural log of x plus the natural log of y. It's very much related to x squared times x to the 5th is x to the 7th. Right? When you're multiplying with exponents, you add the exponents. You're multiplying with logs, you can kind of add the logs. So natural log of x over y is natural log x minus natural log y. Why these are so important is that when it comes to taking derivatives, if you use this property, you just avoided using the product rule. Even better, if you use this property, you manage to avoid using the quotient rule. So it's super important. Again, you don't have to know these, but if you leave stuff together like that, you're going to have a yucky chain rule situation. If you'll split it up, it becomes a lot easier. All right, the A that's out front, do you remember where else that could go? X to the A. In fact, here's how we use them usually. That's a little bit different. Most of the time we use those two in that direction because we want to split it up. This one we usually use in the opposite direction because we'd much rather deal with a coefficient than with an exponent. I mean, you can always use them either way, but to make our calculus life a little easier, that's usually the direction that we go. Okay, domain. Well, you can't log a negative number. It's got to be greater than 0. And if you don't remember what the graph looks like, then you can use the points that we just came up with. If we plugged in 1, we got 0. If we plugged in E, we get 1. Oops. E is like 2.7. So, like, you've got to know that graph. I mean, I know it's a parent function graph from pre-cal, but, you know, how well do you remember it? I don't know, but you need to re-put it into your memory. Now, if you're looking at the graph, the limits are easy. Without the graph, the only way to do those limits for me is to look at the picture. As x approaches 0 from the right, what's the natural log of x doing? Headed to negative infinity.
Yep.
As x approaches infinity, as x goes out this way, natural log, it's always increasing, so it's headed to infinity. I don't know if there's a difference between slow infinity and big infinity, but that's a very low slope. Like it's only slightly getting bigger. Still headed to an infinity, just not nearly as fast as, say, e to the x, which, just shoots way up like that. So, yes, it heads to infinity, not quite as quickly as some other things. Y equals natural log of x has a vertical asymptote. Well, look at the picture. X equals 0. Alright, we're going to X out most of the next section, kind of like I did on the video for the other one. It's a lot of work to get down to the derivative of natural log of x is 1 over x. So there's the derivative that you need to know. It's got stars on it already, so I don't know that extra stars are necessary, but the derivative of natural log of x is 1 over x. Which means the derivative of natural log of u.
1 over u?
1 over u is part of the answer. Then you have to chain rule it. So you can write that as u prime, or you can write it as du dx. Either one. U prime's a little easier, so we'll go with u prime. And so what most books write it as is, you can't see it, is u prime over u. But to me that's easier than writing it this way, but I think of it this way because the derivative of natural log is 1 over the argument and then times the derivative of the argument. So it feels out of order if you write it this way. If you memorize it that way, that's fine. I will almost always write it that way, even though it's not the most efficient way of writing it. It's how I remember it. 1 over the argument times the derivative of the argument. Okay, well, what if our base is not e? That's when things are annoying. Yeah, you're out of luck. So we already know these two. If the base is natural log, that's easy. The base is not natural log.
You mean our base is not e?
I mean, our base is not e. Like, we can go through the derivation, but it's probably easier to just remember it. 1 over x, 1 over natural log of b.
Times?
Yep. Which means you could put all of that in the bottom at once. I do want to compare it to the derivative of, let's say, 5 to the x. Do you remember what the derivative of 5 to the x is? Works a lot like e to the x. It's 5 to the x times natural log of 5. So when you're doing exponents, you multiply by the natural log of the base. When you're doing logs, you divide by the natural log of the base. So to me, those kind of go together because one's a multiply and one's a divide. I mean, the rules are separate, but the log thing kind of goes together. I bet that's supposed to be a u. So that we do 1 over u times u prime times 1 over natural log of b. And again, there's ways you could condense all of that. You could condense that and write it neatly, but then you sort of lose where it comes from. So if you want to just straight memorize it, then you could write it, u prime over u natural log b, but that just, to me, that jumbles up all the pieces. I like to see the pieces. Like the rule for log is 1 over the argument. Chain rule is derivative of the argument. And then, oh yeah, our base wasn't e, so we had to divide by natural log of whatever the base is. So even though that's not the most efficient way to write it, I'll usually write it that way. All right, let's do some examples. So it's one of those that the rule's straightforward, but you just got to know the rule. Number 1, find the instantaneous rate of change. IROC equals calculus slope, so fancy way of saying find the derivative when x equals 2. Okay, so dy dx of a natural log. This is a chain rule problem. Take the outer wrapper first is a natural log. So the derivative of natural log is 1 over the argument. 3x squared minus 4x minus 1 times the derivative of the argument, which is 6x minus 4. Again, that looks a lot neater if you just wrote 6x minus 4 over 3x squared minus 4x minus 1 to start with. And that's how a lot of people memorize it. But I don't know. I lose sight of the chain rule if I write it that way. And then we want to evaluate that when x is 2. So just plug in 2. In fact, here's a good safe stop coming. Yeah, worried about order of operations and squaring things. Not me. I'm not worried about it because I'm not going to do it. Obviously, on a multiple choice test, you're going to have to clean that up. But that's...
Does it turn out to be 8/3?
It does turn out to be 8/3. But I wouldn't do that unless it was a multiple choice and you had to.
Yes.
Right? So like leave it alone so you don't end up doing 6 squared or something dumb like that. Number 2. If g of x equals that mess of a thing, find the slope of the line tangent to y equals g of x in terms of x, as opposed to at 2 or at 4 or at -1. So that just means find g prime of x. But before we do that, I'm going to rewrite this with the power, because what can I do with that power?
Chain rule.
I can make it a coefficient even before we do chain rule. So I'm still doing algebra here. X cubed minus 3x with the 1/3 out front. Still have not done calculus. That's still algebra. Now I can do calculus. So the 1/3 I'm not worried about. It's kind of along for the ride. Chain rule coming, but one layer at a time here. Derivative of natural log is 1 over the argument times the derivative of the argument and once again, that's a great free response answer. Box it up and be done.
Could you clean it up?
But if it's multiple choice, they're probably going to factor out that 3. Maybe even factor out an x from the bottom. Then the 3's cancel. And so I've got x squared minus 1 over x times x squared minus 3. Or my multiple choice answer. This is one of those places where first step is algebra, second step is calculus,
When you figured out that.
and then more algebra and more algebra. So it's like 3/4 algebra, 1/4 calculus. Did I mess something up?
No, I'm thinking. Let me think real quick. No, you didn't mess anything up. My brain just skipped a step.
Number 3. Yes, David.
Whenever we, like in the first step, when you make the 1/3 like in front, how come, like, for the power rule, it's like 1/3 minus 1?
Mm-hmm.
So why didn't you write that?
Because I'm avoiding using the power rule by putting the 1/3 in front.
Mm-hmm.
Putting the 1/3 in front is not a calculus thing, that's an algebra thing. If I left it up there, then yes, I would have to think about the power rule, and I would have a 1/3 and then something to a 2/3, and you would have a real mess on your hands. It should still reduce to this, but put the 1/3 out front, and you don't have to worry about it. Number 3, if h is that, then find h prime. Yeah, well, hold on. I don't want to find h prime yet, because if I find h prime, I have to do 1 over that and then times the derivative of that. So that would be the quotient rule. No thanks.
Not just right there.
Let's do it this way. Okay, that's an algebra rule. That's not calculus yet. That is just algebra. It's been a whole day in pre-cal with expanding and condensing logs. Now we can do derivatives. So derivative of 2x, or excuse me, the derivative of the natural log of 2x is 1 over the argument times, what's the derivative of the argument? It's 2. Those 2's will cancel. Then 1 over x plus 3, and the derivative of that is 1. So 1 over x minus 1 over x plus 3. I like that answer,
But it's a multiple choice.
but it's a multiple choice question. What do I have to do to make my answer look like one of those answers?
You have to get a common
I
denominator.
have to get a common denominator. And even if you forgot that, like look at your answer choices, and it's like, oh, 3 of the 4 have the same common denominator. So pretty sure that
C is
this guy needs, yeah, I'm pretty sure that C is not it. That doesn't look right. So that's x plus 3 minus x all over x and x plus 3. So the x minus x goes away, and that leaves me with B.
Ooh.
4 is on here because it reduces to something kind of nice. It looks terrible, but it's not as bad as it looks.
I'm sure about that.
Well, in the end, it's not as bad as it looks. It's terrible on the path there. So, secant, yuck, but I'm not worried about secant yet. One rule at a time. Derivative of natural log is 1 over whatever we're taking the natural log of.
But do we put the absolute value of lines there?
You don't, because, why is that? I think secant's not always positive. A lot of times natural log has absolute value bars because you can't log a negative number.
Oh, okay.
So that's part of why it works out. What's the derivative of secant?
Secant tangent.
Secant tangent.
So it just turns into tangent.
So it just turned into tangent.
Alright.
So that's one that's like, oh, that looked terrible, and then it was sort of a rigged problem to reduce down to something not so bad. 1 over the argument times the derivative of the argument.
What about this number 5 number?
What's different about number 5?
It's not base E.
It's not base E, so I know I'm going to have to... I know I'm going to divide by natural log of 7 somewhere. Whatever my final answer is, I'll have a log 7 in the bottom. What do you think about taking this 5 and moving it out front?
Okay. Wait, no, we can't do that.
Why not?
Because it's not on the entire 3x.
Yeah. So I would like to, but I cannot.
No touching.
So f prime is, so I'll leave the 2. 1 over 3x to the 5th times the derivative of what's in the bottom. 15x to the 4th, and then divided by natural log of 7. And once again, there's cleanup opportunities. Like, that's my favorite answer. But, let's see. The x to the 4th and x to the 5th can reduce. See what's left here. Natural log 7 is not going anywhere. There's going to be an x in the bottom. There's going to be a 5 times 2 in the top. So there's my multiple choice answer. Algebra. Let's see. What rule are you going to use on number 6? Let's see if we can just name the main rule that's going on here. What rule do you see happening? Product rule. So f prime would be easy. G prime would be a little harder, although not that bad. X squared plus 7 in the bottom. 2x in the top, but also a natural log of 5 in the bottom. So that's one way to... I did it in the right order, I just made it look a little simpler rather than spacing it all out. And then you'd piece it all together. Number 7 looks terrible because, yeah, I can do 1 over all of that, but then that's some awful combination of quotient and product rule.
Could you multiply by cosine first? No.
What I can do is split all this stuff up. So do algebra first so that I don't have a mess on my hands. I have, well, the mess is more spread out, I guess. The algebra step of expanding the log so that you don't have to do the quotient rule or the product rule.
Why is the...
Whoops, I left off. I didn't leave off a 3. I left off the parentheses, I guess.
No, why is the natural log of cosine negative? Like, why is that a minus?
Somebody answer that question. Why is that a minus? Because it was divided by. If it's in the bottom, it becomes a minus. If it's multiplied, it's plus. Cal?
So when you do those types of problems where like it's multiplying in the top and dividing the bottom, do you not have to put parentheses around the first two?
Around the first two. Oh, I see. Like around these two terms. Those. You don't. I mean, you could, but you wouldn't have to. You'd have to be more careful if there were two things in the bottom. You would either have to do minus both of them or minus minus. Does that make sense? So you're right to be concerned, but when they're added, it's not as big a deal. If they were both being subtracted, then you would need to minus both of them or distribute the minus sign, either one. So let's see. We're going to leave this one very unsimplified. 1 over x x squared minus 3 in the bottom, 2x in the top, cosine in the bottom. What's the derivative of cosine? Negative sine. So lots of places to clean that one up. You could reduce the 2's. Sine over cosine becomes tangent. So that's a great free response answer. Multiple choice answer probably does not look like that. Number 8 we won't get to, but I would just say already I'm going to do natural log of g minus natural log of f. That way I avoid the quotient. Alright, today's assignment in worksheet 2. It's just, I don't want to say it's just one rule. 1 over the argument times the derivative of the argument.